Welcome to the lecture on principle of solid state welding processes. So, now in this lecture we are going to discuss about some of the solid state welding processes principles. Many a times when we talk about the solid state welding processes, in that case there is no apparent fusion what we see in the case of arc welding or even you have a lot of requirement of the electricity in the case of use of resistance welding. So, the principle of solid state welding processes overcomes some of the difficulties or in many cases because of the nature of the work which is to be joined, the use of the solid state welding principles are in practice, so that welding takes place with minimum of heat affected zones and maximum of optimized properties. So, what happens in the case of solid state welding processes? Now, the thing is that in this case, in the case of solid state welding processes, you have absence of melting and formation of narrow heat affected zone. So, solid state welding means the parent material, which are the ones like mostly the bars or tubes. So, when they are to be added in a butt shape, then in that case there is a lot of difficulty how will you weld it. Maybe you can have some means of welding by even the submerged arc welding or so in butt, but they will have to do a lot of there may be problems in welding, and then also when we talk about the arc welding or so, in those cases you have the heat affected zones. So, if you are using it for the applications where the heat affected zones requirement is not there or it should be very minimal, in those cases those processes will not be the suitable ones. So, in this case what happens that both the materials which are to be joined, they will be basically rubbed against each other normally, and basically the welding is taking place because of the collisions of metal and mostly because of the rubbing, mostly because of the heating which is caused because of the rubbing or because of the friction, and in that case the heat generated is quite enough to do the melting. So, in these cases normally the heat affected zones are quite narrow. So, only at the very localized place there will be just localized melting will take place, and then the joining will take place. So, there will be very narrow heat affected zones. Now, the thing is that while doing this, while going on in this exercise, the surface oxides are basically driven off, the impurities are driven off, and there is a good bound between the two materials which are to be added. So, basically the metallurgical properties are quite improved in such cases. These processes are having quite a good productivity. The production rate is quite high, and that is why they are the preferred methods of welding. The varieties of these solid state welding processes are available, and among them the very popular ones are the friction welding, explosion welding or cold welding or so. So, we will discuss about a few, and we will try to understand the underlying principle of one or two of these processes. So, coming to the friction welding. Now, if you go by the definition, it is a solid state welding process that produces a weld under compressive force contact of work pieces rotating or moving relative to one another to produce heat and plastically displace material from the faying surfaces. So, you have the compressive force contact, you have two materials or two specimen which are basically brought in contact, and then there is friction generated. So the friction will be generated because of the relative motion between the two. So one may be stationary, another may rotate, and then that may be brought in touch with the next one. So once you have the relative motion between them, then at that surface the friction will be generated. Now because of this friction, the heat will be generated. So depending upon the friction, the heat will be generated. Now at that point, slowly when the temperature reaches so high, then the plastic deformation may start, and that at that time this basically bonding takes place because of the force which is applied on the two material. So this way these the two elements is added, and in this basically normally it was earlier started for the thermoplastic polymers initially before 1950, and then after 1950, close to 1956, the invention was even tried for, the process was even tried for metals, and it was seen that there is successful join even in the metals using this friction welding. Now in this case, some of the traits of this friction welding are like this, that in this there is no filler metal. So as we discussed that you have two elements, so there will be two maybe rods or bars or so, and then at they will be just touched in butt. So as we have seen that in resistance welding, normally when we pass the resistance you go for lap type of joints. Here normally we go for the butt type of placing. So there is no filler metal which is there at the interface. So you are just touching the two surfaces which are to be joined. There is no flux or shielding gas. So these are the advantages, as we have discussed also in the case of resistance welding. So once you have you don't have the use of flux, it means the chances of entrapment of these fluxes in that interface will be minimum. So that way any bad effect or ill effect of these flux entrapment you can be dividing off, and also there is no shielding gas requirement, so that way it will be cheaper. Joint is basically similar to the ones which is produced by electrical resistance butt welding process of flash and upset welding. So it is something similar to that, so where you have you go to a state and then you apply the pressure, and then that way you have the joining process taking place. So in the case of resistance welding, you apply the current, so you must have a proper current source. A large amount of current is required in those cases, but here that requirement is less. Here you need the current maybe for the movement of the parts, so that way your requirement of current may come into picture. So that way you have the good quality of weld is produced in the case of friction welding. Now we will discuss about the sequence of the different steps which occur in the friction welding. So as we see that you have 4 steps, A, B, C and D. Now what happens that initially this is you see that there is rotation of A. So A is rotated and B is stationary. A is rotated, and so this part is rotated, another part is stationary. So slowly that will be brought together. So in the step B, it has been brought together here. It was it is this part is only rotating and this is stationary, and this part is moved to this side, and then it is brought in and touched to this point. So, at this interface they have a common interface now. So, they will be touching, and during the touching, after the touching you have so then you are applying the pressure also. So, you are applying pressure. Now, what happens that once you apply the pressure, in that case you have the generation of friction at here. So, at this point the friction will be generated, and slowly you will have the at this point the forging and breaking takes place. So, once you have slowly it will come and then it will stop. So, you apply the pressure and then it gets stopped, and as you see that this motion is now stopped. So, once you reach there at that point where it is ensured that it has melted, then you apply the pressure, and that is a breaking process, and as well as the forging process. So, both the processes work here in this case, and then in that case this is being joined. So, once it stops, then while stopping it gets joined because of the localized melting of the material in this case. So, these are the sequence of the different different steps in the case of friction welding. Now, what happens that normally you try to weld the cylindrical type of pieces like rods or tubes, that also can be welded using this friction welding process. Now, let us see the different modes of this friction welding process. So, you can have the different modes in this way. So, this is known as the basic mode, and this is the simplest mode, where you see that you have the left part is being rotated, and the right part is not rotated, and basically the pressure will be there applied from both the sides. The temperature will go, if you take the steels suppose, then it may go as high as about 900 to 1300 degrees centigrade, where after when the pressure is applied, then in that case the joining takes place. So, that is why because of the friction this joining takes place because of the heat generated. That is why it is known as solid state welding, because both the parts are in solid state and they are getting joined. Now, the next part is the one where you see the counter rotation. So, this part when you require high relative velocities, in that case one part will be rotating in suppose clockwise, so another part will have to be rotated in the anti-clockwise direction. So, their sense of direction will be opposite to each other. In that case you will have larger relative velocity, and normally it is required for the low diameter specimen. So, what happens that in the case of low diameter specimen, the chances of otherwise will be otherwise joining, because the at normal speeds the chances of joining will be smaller. So, because the heat generation will be may not be adequate enough. So, what you do is that in that case you rotate them in opposite direction, so that the larger amount of relative velocity is maintained, and so the heat is generated in those cases. If you look at the third point, that is center drive or splicing, it is known as. Now, in this case you are able to get twin welds. So, you have the possibility of getting the weld at these two places. So, suppose you have one part in the middle. So there are two pipes on both the sides, and in between you have to add to these two parts once itself. So in that case, this kind of mechanism is adopted. Because you have two very long type of pieces which are very difficult to be rotated. In those cases, they are stationary. So these two long pieces which are there on this side and this side, so they will be stationary, but then in the middle you will have a shorter piece which can be rotated at a very high speed, and then you apply the pressure from both the directions. So this way you can have the joint to join off these two long pieces with this intermediate piece, so that you have twin weld production in this case. Twin weld is also produced here in this case, where you are rotating these two left and right pieces, and middle part is not rotating. So this way you see that you have different mechanism of rotation, and then you get the different kinds of welds. Similarly, you have center drive, so splicing in this case. You have twin welds again here. I think they are the same ones. Then you have the center drive, that is dual production. Now here this is one center drive dual production, and this is known as the radial ones. Now here in this case, in these cases what you see is that the axis of rotation and the application of force, they are basically same in all these cases, but in this case the point of the direction of the force basically is perpendicular to the axis of rotation. So in the case of this radial welding, as you see that you have the application of force in the perpendicular direction to the axis of rotation. So that way you make the weld. So basically when you have to put a collar on the shaft, so this is how you put the collar, you try to give the rotation to this collar component, and then the inside this shaft is rotating, and then you apply the, so because of the friction they will be welded to it. So this is the example of the radial mode of friction welding. This is the typical friction welding machine, where you will have a rotating chuck this side, then that will be sliding, so you can slide from this side, and then you have the thrust cylinder that will be used for giving the thrust or pressure, axial pressure, so that you have the adequate pressure to weld. Then you have the brake mechanism here, so that it gets rotated when stopped in the end, and so that after that the two parts are joined. So this is the typical friction welding machine. Now if you generally try to analyze a friction welding process, so what we see is that we know that the frictional force is nothing but F is mu into L. So if L is the normal load, in that case the frictional force will be mu into L. So that is utilized. So as you apply the normal load, as you apply the load on this, the frictional force will go on being more and more. There has been many researches and many scientists, and some of the findings are like some people have, because it also depends upon the contact area. So sometimes frictional, that force is taken as that a constant times the area of contact plus a constant times the normal load. So that constant, so alpha into A plus beta into L. So alpha and beta, suppose there are two constants. So in that case you can define like alpha, so F will be alpha into A plus beta into L. So L is the normal load, A is the area. So beta will be nothing but close to the mu, and that way because alpha A is normally small. So that's what F equal to mu L, we have that value coming up. If you look at the stages which occur in the case of friction welding, normally it occurs in the case in 4 stages. In the case of friction stir welding, you have 4 stages. In the first stage, you have the dry friction when they are just touching each other. So there will be dry friction that is generated, and the torque will towards the end of the first phase, the torque will somewhat increase. Now once you go to the second stage, now in the case of second stage, that is a stage of seizure and rupture. So that occurs in that second stage, and towards the second stage, your torque value towards the end of the second stage, it goes to a high value. Then after that you have the plastic deformation starting, because they are there. So once the plastic deformation starts, the torque value goes on decreasing slowly. So the torque value will decrease from there, and in the end, when you do the braking and forging, again some torque value will go on little bit increase, and then further it will decrease. So there is a variation of the torque value, and that is seen normally in the case of this friction welding. So initially, if you take this as the torque, and then the torque is basically changing with respect to time. So if you take the time like this, so initially it will go on that. So this will be your first stage, and then after that it will be going, and then slowly once it will go on increasing in the second stage, and then here it will be constant, and then it is increasing to maximum in the second stage. Now in the second stage, where the seizure and rupture takes place, after that the deformation will start, plastic deformation will start. So again it will come down, and then after that this will be the third stage, which will where the plastic deformation takes place, and then in the fourth stage again it will increasing, and then it will be decreasing. So that will be the final stage, and in that final stage you are braking and forging taking place. So this way there are 4 stages in the case of friction welding taking place. Now there are different variants of friction welding. In the case of friction welding, you have the variants like one is inertia welding, another is friction stir welding. So in the case of inertia welding, the inertia is used by using the flywheel, and so flywheel will be attached, and then the flywheel so you will have the power attached to that section, and then since we are using the inertia of that flywheel, so you will have moment of inertia attached. Based on that, you will have I omega square will be there. I will be in a moment of inertia of the flywheel, and then you will have omega square, that is based upon the rotational speed. So that concept is used for the inertia welding, and then you have the friction stir welding. So in the case of friction stir welding, basically you are stirring, there is a stirring action in the zone where the basically the welding has to be carried out. So you will have a tool, and then that tool is going to rotate in that particular zone, or in the joint which is there, and then because of the plastic deformation and because of the shearing action, the bond will take place. So that is friction stir welding. So in the case of friction stir welding, you have again varieties like hybrid friction stir welding, friction stir spot welding, friction stir surfacing. So these are the different varieties. One of the component to be welded is clamped in revolving chuck with a flywheel attached to it in the case of inertia welding, and other is clamped in a fixed position. So that way you have that, and then the chuck with flywheel is raised to pre-designed speed so that to store much more energy. After that, the work pieces are brought together, and then axial force is applied, and friction will be developed at the fairing surfaces which provide the braking force. So, that is how this welding is taking place. So, there is normally is a shorter welding time, but then the application of pressure is also important in these cases. This is the schematic of or setup of a inertia welding process. So, as you see that you have a flywheel attached here, and then this is a spindle, and then you will have non-rotating vice. So, that will be brought in contact with this, and then that way, since this is the inertia of the flywheel is used, that is why we use this term known as inertia welding. Now, in this case of inertia welding, you have certain there are certain traits of this inertia welding. The thing is that with the continuous drive friction, there is certain difference in this case. In the case of continuous drive friction, the welding is carried out at constant spindle speed, whereas in the case of inertia welding, it starts at high speed and then slowly it decreases. So, you will have, that is why you will have the shorter weld time in this case. Now, in this case the heat will decrease, and you will have the increase of torque also, and there are certain welding variables like you have inertia of flywheel, then you have speed of flywheel. These are the variables which affect the quality of the weld. So, these parameters are to be seen. As you know that the inertia of the flywheel can be used for finding the energy. So, that will be half of I omega square. So, I that I will be m into k square. So, depending upon k as the radius of gyration, you will have mass of the flywheel, and k will be radius of gyration. So, based on that you can find I, and then omega will be based on the number of rotations. So, 2 pi n by 60. So, if n is the RPM. So, based on that you can have the energy which is associated with such processes, and also the velocity also is one of the factor. So, velocity normally has been seen that you will have 150 to 450 around per minute, meter per minute of the velocity is required for forging of the steel bars. Similarly, you have the pressure, heating pressure, and that is 150 to 205 Newton per mm square. So, these are the operating variables in such cases. There are even other variables which need to be looked into as you go to the higher studies, or in a higher other courses you can study specifically for such processes. The very important process among them is the friction stir welding also. So, as you know that in this friction stir welding you have localized forging of weld region to produce joint. Plates to be joined are held in compression and rigidly clamped to machine bed during welding. Then using a non-consumable rotating tool, and process parameters are tool RPM, travel speed, tool dimension, and down force. Now, this is the schematic of a friction stir welding. As you know, in this case you will have a tool here, this is in terms of a pin, and then you will have, this is the profile surface. So, this is the solder cone known as, and this pin basically goes into this recess, and then it rotates and progresses along this length. So, this way what happens, it deforms plastically the material which is in contact with it. So, the shearing is carried out. You will have two sides advancing. So, once it is rotating in this direction, as you see that this is rotating in this direction. So, this is rotating in this direction. So, this direction is known as advancing side, and this is known as retreating side. So, you will have two sides, and they will be rotating. So, these are the basically based on that you will have the change of microstructure or so. then you will have the formation of different zones in this case, like heat and deformation affected zone as DAZ. Then you have the thermomechanically affected zone TMAZ. So you will have different kinds of structures you will be getting. In such cases, you will have plastic deformation as well as heating going on in this case. So, coming to this FSW, now in this case what happens that first you plunge the tool, then the tool is plunged so that the solder surface touches the solder is touching that surface to be joined, and then it is basically given a feed in this direction. It's given, this is rotated and also given a feed in the direction of welding. So that way stirring will be taking out, and that stirring will produce the bond between the surface. So normally aluminum alloys, aluminum copper or aluminum copper lithium alloys are mostly on aluminum alloy. It has been proved to be very successful. Very small energy requirement is there in this case, only for so the movement and some clamping pressure or so. So very energy efficient process this is as compared to other joining processes related to arc welding or even the resistance welding. There are many advantages, no need of filler, then you have a minimum of the joint edge preparation, no embedded oxide formation possibilities, then you have good joint strength and all that. The only limitation is that you have to have the clamping facilities, and its varieties are many, like hybrid, where you heat the portion ahead of the ahead when you are going to weld. So at the front point you can heat it so that the requirement of the force to move will be smaller and you will be better welding properties. Then you have spot also, spot welding can also be carried out by having some attachment, and you can do the spot welding. So it's said that it's about 99% more efficient than the case of electric resistance spot welding. So like that. Then one of the other type of solid state welding process is the explosive welding, where the pieces of metal are basically joined under impact. So you apply the impact. What happens that when the impact velocity is less, then you have the smooth or flat surface. Because of that the bonding will not be good, but when it becomes to more, it has a high impact velocity, in that case the surface is wavy, and so joining takes place. So between similar or dissimilar materials, large size components can be, and difficult to weld components can be welded. For critical components it is used. So as you see that when it is quite explosion is done heavily, then in that case you have a wavy interface, and then in that case you are the attachment takes place because of some projecting type of motion. So you will have the explosion taking place, and then at that localized point you will have the welding taking place. So these are the different examples, these are the different processes based on solid state welding. There are other than that also called cold welding, cold forge welding, or so hot forge welding is there. So all these are based on the concept that you will have the proper condition of such a condition that you have the attainment of temperature, or you may have some cases like you have diffusion bonding also occurs, where because of the diffusion at some temperature the diffusion bonding takes place. So these are the different other processes which are based on the solid state welding, which can be studied, and you can have more understanding about such processes. Thank you very much.